Hi everyone. Today let's talk about session 7.3, Trig Substitution. I would say trig substitution is the hardest topic in Calculus 2. So everybody, please pay much more attention in this course. Okay, if you have any questions, feel free to print screen and ask me. Okay, so big idea. There is a special kind of substitution called trig substitution to deal with integrands of the form square roots of a squared plus or minus x squared and square roots of x squared minus a squared. So do you remember when we talk about the odd length? We said there are so many functions we're not able to integrate, and especially the square roots. In general, square roots of, if I just write x to the fourth minus 5x cubed plus 7, in general, we won't be able to integrate this function, right? But if you see square roots of a constant plus or minus x squared or a square root of x squared minus a constant, then we can use trig substitution to solve the integral. Okay? So big skills. You should be able to make an appropriate substitution for the integrands of the form square roots of a squared plus or minus x squared and square roots of x squared minus a squared. Okay, so here we have three types of integrands. Okay, so first of all, I want to review with you the trig identities. So I want to emphasize the one sine squared plus cosine squared equals 1, and the one tangent squared plus 1 equals secant squared. Okay, let's look at the first one. Square roots of a squared minus x squared. Do you think this guy looks like cosine theta squared is 1 minus sine squared? Because see, they're like constants and minus the variable square. So I think this guy looks like this. So when you see the square roots of a squared minus x squared, the substitution is let x be a sine theta. So here a is arbitrary constant, okay, just a number. So here, if you let x be a sine theta, then, well, what is this guy? Well, this is square root of a squared, x is a squared sine theta squared. You see, we can factor out the a squared, and we can also pull the a squared outside the square root. Now it becomes a. Then what we left, we have 1 minus sine squared. Wow, square root of 1 minus sine squared. This is actually square root of cosine squared. Okay, and what's square root of cosine squared? That's actually absolute value of cosine. But if our angle theta is between minus pi over 2 to pi over 2, see? On this region, so my cosine is actually positive. So absolute value of cosine is just a cosine theta. Okay, so that's why here, when you see the square roots of a squared minus x squared in the integral, your setup is x equals a sine theta. And the square root of a squared minus x squared equals a cosine theta. So far, so good, everybody? Alright, next. Okay, a square root of a squared plus x squared. Does it look like constant plus variable is variable? Does it look like this? So we let x be a tangent theta. Well, then this guy is square root of a squared plus a squared tangent theta squared. We can factor out the a squared and pull it outside of the square root. Now it becomes a. Then we have 1 plus tangent squared. Well, that is secant squared. Square root of secant squared is absolute value of secant. But because on this angle, the secant, what's the secant look like? You know, the secant is 1 over cosine, so it's like this. So it's positive, so that's why absolute value of secant is just secant. So far, so good. So that's why when you see square root of a squared plus x squared, our setup x equals a tangent theta, and the square root term becomes a secant theta. I love to make some story to help you to memorize. So think about it. Sine and cosine, they are couple. So when your setup is a sine theta, and then I ask you, who's the wife of sine? Okay, then the wife of sine is cosine. That's why the square root of a squared minus x squared is a cosine theta. And then so tangent and secant, they're couple. So who's the wife of tangent? Secant. Okay, and last one, if you see square root of x squared minus a squared, it's like a variable. Square minus constant, does it look like this trig formula? So that's why you let x be a secant theta. Well, then this is a squared secant theta squared minus a squared. We can pull out the a squared out of the square roots. It becomes a square root of secant squared minus 1 is square root of tangent squared. That's absolute value of tangent. But because on the angle, the tangent is always positive, so that's why this is a tangent theta. And how do you remember? Okay, so if you see square root of x squared minus a squared, let x be a secant. And then who's the couple? Who's the husband of secant? Tangent. So far, so good. So sine and cosine, they're couple. Tangent, secant, they're couple. And when we do this setup, we only use the sine, tangent, secant. We don't use the co-function. So don't use cosine, don't use cotangent, don't use cosecant. So there are three functions, three choice: sine, tangent, and secant. Okay, and then depending on what the integrand look like. Okay, so let's practice. Let's practice the setup. Okay, let's look at this one. Constant minus x squared. What is the setup? That is a sine theta, right? And what's the a? Well, a squared is 1, so a is just 1. So the setup, x equals a is 1 and sine theta. This is the setup. And after you write the setup, what is the square root of a squared minus x squared? A cosine theta. Okay, so that's why when you see the integrands, you know the setup, and then you know who's the wife of that. So far, so good, everybody. Okay, now continue. So what is dx? See, you want to change this integral of with respect to x, change it in with respect to theta, right? So dx, well, we're going to take the derivative of x. So the derivative of sine is cosine theta, d theta. And then our integral becomes, so square root term is cosine theta, but the dx is actually cosine theta, d theta. Okay, do you remember I always tell you that don't forget our baby dx? And in this session, our baby dx is so important. Much more important. Because in the previous integral, if you forgot to write dx, it won't change your answer. If, for example, if you integrate x cubed, if you forgot to write dx, you still integrate x cubed. But in this session, if you forgot the dx, you're integrating a different functions. See, because dx is cosine theta d theta. If you don't write this term, you're only integrating cosine theta. But you actually need to integrate cosine square. And the power make a big difference. Remember, in session 7.2, depending on the power is odd or even, we use completely different method. right? For example, the sine and cosine, if it's odd, we're going to use substitution. But when it's even, we use the double angle formula. So the power, just one copy of the sine or cosine, it really make a big difference. It changed the entire problem. It changed the methods. So I hope when you solve the problems in this session, after you set it up and after you change to the integral with respect to theta, please double check your work. Make sure you don't miss anything, and then you can continue. Otherwise, you're just working with a wrong integral, and then everything's follow that is gonna be wrong. So everybody be careful. That's why I said this session is challenging. Is one, I would say, the most challenging topic in Calculus 2. You need to be very, very careful, and you need to be familiar with the trig identities. Maybe many of you didn't memorize the trig identities, but today, if you want to be successful in this topic, please make sure you are familiar with the trig identities. And if you can remember, I made the hexagon. So in the first week of class, I helped you to build a hexagon. Do you remember? To help you to memorize the 6 trig identities and also memorize the double angle formula. And those, we're gonna need them a lot in our course, especially in this session and later on. Okay? So right now we have cosine square. Okay, so cosine square, you see that we get the integral that we learned in 7.2. The power is even. What do we do? Which case? The third case, right? So we use the double angle formula. So cosine square is 1/2 plus 1/2 cosine 2 theta. And I hope that you memorize those formula, okay? And sine square is 1/2 minus 1/2 cosine 2 theta. Okay. Alright, so integral of half is half theta. Integral of cosine, wow, that is the sine 2 theta, but we actually divided by 2. Alright, so next we want to change theta back to x, okay? But before we do that, we want to make sure we want to have the sine and cosine function in terms of theta instead of 2 theta. So here we're going to use the double angle formula for sine 2 theta. Sine 2 theta is 2 sine theta cosine theta plus c. And they cancel, so 1/2 theta plus 1/2 sine theta cosine theta plus c. And then next, what do we do? Okay, we're gonna draw the triangle. So see, I have the triangle here. So how do we draw a triangle? Okay, you draw a triangle, right angle triangle, and this is theta. And then look at the setup. So look at the setup. Okay, so sine theta is x. X is like x over 1, right? Sine theta is the opposite over hypotenuse. So it's like the opposite is x, the hypotenuse is 1. Then what is the adjacent? By the Pythagorean theorem, this is 1 minus x squared. So that is why here, what is theta? Well, theta, you take inverse sine, arc sine on both sides, right? So this is 1/2 theta is arc sine of x, and sine theta was sine theta opposite over hypotenuse. That's x. Cosine is adjacent, which is square root of 1 minus x squared over hypotenuse, which is 1. So this is our final answer. Okay, so what are the steps? First, look at the integrand. Which kind? Constant minus x squared. Then our setup is a sine theta, right? And a equals 1 in this case. So, and you also figure out what is the square root term. The square root term is gonna be, who's the couple? So that's cosine theta, right? And then you take the derivative of x. The x is cosine theta d theta. Then you change the integral in terms of theta. And don't forget the theta, okay? And then you will get a trig integral, and use the knowledge we learned in the previous session 7.2, okay, and solve the integral at the end. So express your solutions in terms of sine, cosine, the theta. It's not only sine, cosine, it could be tangent, secant, whatever, but the angle must be theta. And then you can draw the triangle, and depending on your setup, you can, the angle is always theta, and depending on the setup, you can figure out the sides and use the Pythagorean theorem to find the remaining sine, and then you can plug the x back. Okay? So take a deep breath. We'll do tons of examples. Even though it's hard, but we'll do a lot of examples. Hopefully, we will learn all the tricks. Okay, so here you have constant minus x squared. So what is the setup? Is A 4? No, A is 2. So we have 2 sine theta. So far, so good, everybody. And then, who's the wife of sine theta? Cosine theta. And what is dx? Well, dx is 2 cosine theta d theta. And then our integral becomes, well, the square root is 2 cosine theta. Well, dx is on top, 2 cosine theta d theta. X squared, so 2 squared sine theta squared. So far, so good, everybody. Alright. Oh, do you see all the 2 cancel out? And we have cosine squared over sine squared. What's cosine over sine? Cotangent. Okay, you might ask, oh, why do I want to express into cotangent? Well, think about it. If you have cosine squared over sine squared, well, this is like product of sine and cosine, but the power of cosine is not odd. The power of sine is not odd. And yeah, they both even power, but the sign is in the denominator. Our double angle formula only works if the cosines, even power of cosine and sine, they are in the numerator. So in this case, we cannot use the method that we learned in the previous session. So that's why I try to express it in terms of other trig functions. And we realize cosine over sine is cotangent. Cotangent square, can we integrate cotangent square? Okay, so this is the place why you need to be familiar with the formula. Let's check our list. Do you know integral of cosine? Yes. Do you know how to integrate sine? Yes. Do you know how to integrate tangent? Yes. And cotangent? Yes, we just learned it last class, right? Secant? Yes. Cosecant? Yes. And also secant square and secant tangent. Oops. And cosecant square and cosecant cotangent. So these are the ones we know how to integrate. Well, this one, we don't have a formula for it. Well, then try to relate to some of this one. Which one we can relate? Alright. Do you know the trig identities involve cotangent square? That is cotangent square plus 1 is cosecant square. C is related to cosecant square, which we know how to integrate. So that's why in this session, you need to be familiar with all the trig identities and all the antiderivative formulas. And then you know which one you want to relate it to it. Okay, so yeah, this session is like a combination of a lot of concepts we learned before. So cotangent square is cosecant square minus 1. Well, integral of cosecant square is what? Negative cotangent. right? The root of cotangent is minus cosecant squared. Integral of 1 is theta. Alright, finally, we draw the triangle, and our setup, sine theta is x over 2. See? Opposites, x hypotenuse 2. Pythagorean theorem, 4 minus x squared. So, what is cotangent? Cotangent is adjacent over opposite. Adjacent over opposite. Theta is at sine of x over 2. And then plus c. So this is our answer. So far, so good? Yes. So I hope you can, if you haven't memorized all the formula, I hope you do today after class. Okay? Let's continue. Next, so square root of x squared minus 9. Oh, so we have a different setup. So x is gonna be, any guess? 3 secant theta. Okay, and then who's the family member of secant? 3 tangent theta. Right, everybody? And what is dx? The root of secant is secant tangent. Alright, so dx is actually on top. So on top we have 3 secant theta, tangent theta, d theta. Well, x squared is 3 squared 9, secant theta squared, square root, 3 tangent theta. So far, so good, everybody? Yes. Sometimes if a student forgot to write the dx, forget the baby, then he might result into an integral that we're not able to solve. So for all the integrals I asked you in your homework and exams, there must be a way that you can solve it, okay? So let's simplify. So 3 cancel, tangent cancel, secant cancel, one copy. So we have 1 over 9 integral of 1 over secant theta d theta. Okay, do you know what is 1 over secant? That is cosine. See? You're going to be familiar with the trig identities. And integral of cosine is sine theta. So far, so good? Yeah, so it turns out, oh, this integral is not that bad, right? Very easy. Once you change to cosine, it's easy. Okay, next. Draw the triangle. So, secant theta. So based on the setup, solve for the trig functions. X over 3. Secant is, what is secant? 1 over cosine. So hypotenuse over adjacent. Then Pythagorean theorem, we get this. What is sine? Sine is opposite over hypotenuse, right? So this is our answer. So far, so good, everybody? Okay, let's continue. Oh, do you see this one? Our setup is the same, right? Because we still have the square root of x squared minus 9. So let me just copy down here really quick. X squared minus 9. Who's the couple? 3 tangent. By the way, some of you might want to prove this is 3 tangent. You don't need to, because we already went over in class. You can directly say this square root term is 3 tangent. Okay? And then dx is 3 secant tangent d theta. Alright, so what is our integral? Well, x is 3 secant theta. Dx, 3 secant theta, tangent theta, d theta. Square root term, 3 tangent theta. Alright, let's cancel it. Oh, 3 cancel. Tangent cancel. What's left? 3 secant square. Good. We know how to integrate secant square. That is tangent theta. right, everybody? So we're ready to draw the triangle. Set up. Secant theta is x over 3. Secant 1 over cosine. So cosine is adjacent over hypotenuse. So here, hypotenuse over adjacent. Pythagorean theorem. And what's tangent? Opposite over adjacent. Oh, so it's square root of x squared minus 9 plus c. Oh, do you know something I realized? Besides trig substitutions, we can also use u substitution. So in this example, we can also use u substitution. Do you realize if we let u be square root x squared minus 9, du is 2x dx, then our integral becomes, so x dx is 1/2 du. So 1/2 and then du over square root of u. So this is u to the minus 1/2 du. Is we add 1 to the exponent, so 1/2, and then you multiply by 2. Oops, cancel. So u is x squared minus 9. See? We have the same answer. So in this problem, we can actually use both ways. Trig substitution and u substitution to solve. Of course, which way is easier? U substitution is easier. So sometimes if I give you an integral in the exams, because it's going to be chapter exams, right? It's going to be everything, so involve all kinds of possible integration techniques. So then you think, okay, what method you can use? Like this problem, we can use trig substitution, and we can also use u substitution. You realize that, okay, then we should use u substitution because it's easier. So far, so good, everybody. Yeah, so think more before continue to actually solve the problem. So think which way is easier. All right. Next, example 2, we're gonna work on the definite integral. So how do we work on the definite integral? Well, I would say we solve the indefinite integral and then we can plug in the bounds for it, right? So let's look at this problem. Okay, so do you see 3/2? It's not square roots, but it's like square roots then cubits. So we still have a square root inside our integrand, right? So then we can use u substitution. Trig substitution, I mean. Okay, so x squared plus 9. Okay, so remember, if you see square roots of x squared plus a squared, then you let x be a tangent theta, right? But now I see square root of 4x squared plus 9. So you can think of this guy as 2x squared plus 9. So when you set it up as 2x equals 3 tangent theta. See? This guy, x goes here. This a goes right here. Here, the 2x goes here. The 9 is 3 squared, so that the a goes in front of the tangent. Okay, so we have the setup is 2x equals 3 tangent theta. And then the square root term is still 3 secant theta. Who's the family member of tangent? Secant, right? So the square root term is still 3 secant theta. Then when we differentiate, we have 2 dx equals, by the way, we can solve for x first. So x equals 3 tangent theta over 2. So dx is 3 over 2. The derivative of tangent is secant squared. So far, so good, everybody. Okay, and then let's calculate our indefinite integral. So x cubed is 3 cubed, 27. 2 cubed, 8. Tangent theta cube. Oop, the dx is actually on top, right? So dx is 3 over 2 secant squared d theta. And the denominator, the square root is 3 secant, but this is cubed. So 3 squared, 27, and secant theta cube. Is that okay, everybody? Alright, this cancel. So we have 3 over 16. Those are the coefficients. And then secant square and secant cube cancel. We only have a secant in the denominator. So far, so good, everybody. Alright. So here there are 2 ways to solve. You can see the power of tangent is odd. So you can split a tangent, actually secant tangent at the end and solve it. The other way is you can express this in terms of sine and cosine and use the sine and cosine rules to solve it. Okay, so let's use the tangent secant rule first. So what do? We split a tangent at the end. Split a tangent is not enough. We actually need secant tangent. Remember the tail? And what do? Okay, so you had secant theta before, but you want to multiply by secant theta, so you also need to divide by another secant theta. Remember, borrow money from the bank. And now, what do we have? So, and let's see here. Okay. Let's see here. Because secant tangent is the derivative of secant, so we change the tangent in terms of secant. So tangent is secant squared minus 1 and over secant squared. And then we have secant theta, tangent theta, d theta. Yeah, sometimes you get lost and don't know. You should change the tangent in terms of secant or change the secant in terms of tangent. Look at the tail. This is the derivative of secant, so we know that u should be secant, du is secant tangent. Yeah, you can see this example is harder than the previous example we see. So you can see the problems can be more and more complicated. Just the different powers can really change the problem a lot. Okay, so next we have u squared minus 1 over u squared du. Let's split. So that's 1 minus u to the negative 2 du, right? Yeah, we can write it into the standard form and make it convenient for us. The next step, we can use power rule. Okay, integral of 1 is u, not theta. Here, we respect to u, okay? U to the minus 2 at 1, u to the minus 1 over minus 1, so we flip it. And plus c. So what is the u? The u is secant, so we have secant, and this is 1 over secant. Don't put secant inverse. That is odd secant. Okay, be careful. And then now, what is secant? So we draw the triangle. So tangent theta, look at the setup. Tangent theta, solve for it, is 2x over 3. Opposites, 2x. Adjacent, 3. Hypotenuse, 4x squared plus 9. And you can see this term always match with the integrand in our integral. Okay, so secant is 1 over cosine. So 3 over 16, 1 over cosine. So hypotenuse over adjacent. 1 over secant cosine. So adjacent over hypotenuse. And plus C, right? And finally, we still need to plug in those bounds. So let's see. I don't have much space here, so I don't copy the whole function, right? Okay, let's just evaluate. Let's plug in. So I put dots here because I ran out of space. So here we plug in 3 root 3 over 2. So 3 root 3 squared is actually 27. 27 over 4 times 4. 4 cancel. 27 plus 9 is 36. Square root of 36, 6. 6 divided by 3, 2. Okay, and do you see this guy is the reciprocal of the previous term? So this is 1/2. Minus, oh, we plug in 0. Plug in 0, let's see, what do we see? Okay, so I should not put a parenthesis. So when we plug in 0, square root of 9, which is 1, and here we also have 1. Oh, do you see they cancel? And we get 3 over 32. So this is our answer. So far, so good, everybody. Do you have questions about how I get this 2? Even though I say it, but I didn't write it down. That is 4. 3 root 3 over 2 squared is 27 over 4. So that's why 4 cancel. 27 plus 9 is 36. Square root 36 is 6. 6 over 3 is the 2. Okay, everybody? Okay, so let's continue in the video parts B. See you soon.